Sometimes we need to look up information based on values in two different columns, Ford Explorer or Chevy Blazer. Let's go and see how we can do this. Notice up here I've called this My Make and this My Model. Here I've given it the name Make and this column Model and this column Code. So we say, and this is an array index of code, but then match my model concatenated with my make. So that would come out to Ford Expedition, and then compare it against the concatenation of each of these and make it exact. The best way to see this is to evaluate the formula. So using that, notice the code, everything in F2 through F12, match that my make, Ford, and my model, and concatenates that to Ford Expedition, one word. Then it's going to compare it to make, and concatenated with models is Chevy Blazer, Chevy Tahoe, etc. I do the match, and it says, oh, I found that in position 4. So now we'll go 4 down under code, and that's the F229. This could be very useful in things like tables where the first name and the last name are in different columns, but we want to match both together when we do the lookup. Let's move on to address lookup. The address function will return the cell address based on information given it. We give it the row number to use as a cell reference, the column number, and then we tell it what type we'd like it to be. That's optional, absolute, absolute row, relative column, relative row, absolute column, and just make it relative. We also have an option of turning it into a different style. We use the A1 style, that is, columns are numbered A, B, C, D, E, and then the rows, but there's an R1, C1 style. You can make this your spreadsheet style by going to your option. R1 would be the row number, and then C1 the column number. The columns are then numbered 1, 2, 3, 4, 5, etc. Then also you can show which sheet it is on. Let's look at this example. First one. Everything in light yellow here, you'll notice, is called data. This is also called target. So we want to see where target falls with inside data. Let's look at this formula and see how it works. Evaluate. So I want to find the row of data. It takes the array data and finds the upper left-hand cell and gives the row as row 34. Next, I want to match target, which is 46, with data, and I see that it's the 6th item. So 1, 2, 3, 4, 5, 6. So now I add row 34 with 6, and I get row 40. But 46 is in row 39. What happened? We counted this first cell twice. So I want to subtract 1, and now I'm in row 39. Next, we take the column of data, and that's column D, which is 1, 2, 3, 4. And so we get that. The address then is D39, absolute. Let's do that again in the next example, but this is a horizontal orientation. So again, I'll use this. This is target 1 and data 1 this time. Evaluate. And we get data 1 is D55 through J55. The row of that is 55. Column of data 1, the upper left-hand cell is in column D, so it's 4. Match now target 1 with data 1. 35 to all the different items, and it has to be exact, and we say, oh, well, that's the 4th item, 1, 2, 3, 4, 35. So we combine those, that's 8, that would be H So we're one column over, so we subtract 1. Again, we've double counted this first cell, and we get the address as G55. Okay, I do have the cells hidden below here. Notice I'm just going to put them in red. So you have all the information on how to solve this. Let me go through that with you. I'm just going to copy this and paste it here. And then I'm going to come over here and remove the single quote. And we get an NA. Why did we get an NA? That's right, because this is an array formula. So Control-Shift-Enter. Let me do that. Click up here, Control-Shift-Enter. At A37. Let's evaluate that and see how it works. So formula, evaluate, and we have the row of student data. That's this whole area here, and this is students. So the row of student data, that's on 25. That's the first cell in that array. Then the target value, the 6,700 here, minus the student data, it's going to compare it to each one of them. So it's going to take 6,700 minus each one of those values. And then when I get the difference between them, some are positive, some are negative, I'm going to make it absolute so we can compare easier. Now that it's absolute, I'm going to take the smallest value, minimum, and it says, oh, well, that's 100. So there's one within 100 of the 6,700 we have in the target cell. So which one is that? Well, we're going to match it to find out. Notice we're going to do exactly the same thing, but have all the functions available. So evaluate the target minus the data, absolute, and then now we can compare the 100 to see where it fell in that array. And we do the match, and it's the 13th item. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is the one that's closest in value to 6,700. We add that to the 25, and again we subtract 1 because we're double counting the very first cell. So it looks like it's row 37 right here. Now we take the column of student data, which is 2, and this time we're going to want to offset it to get the students. So the offset, that's this name of the cell up here with the -1. We'll add that -1 to 2, and the address is row 37, column 1, or A37. And we'll close this. Now to see what the name of that person is, we'll take and use the indirect function. So equals indirect of whatever we found before. It says, oh, well, that's Paul. Paul is the one that's closest in value. Of course, we could combine those two formulas into one, as is shown here in G31. We have a lot of power in the spreadsheets in how we can pull information together and look up values. Enjoy.